open source data analysis and manipulation tool. Data analysis and manipulation tool built on top of the Python programming language. It provides highly optimized performance with backend source code, which is purely written in C language and Python language. Okay, the backend of pandas is created using your C and C, C++, and Python, all three of them. Okay, so let's continue. Okay, now in NumPy we studied one topic called as arrays, right? In NumPy we studied one topic called as arrays. Okay, here in pandas we are going to study. Here in pandas we are going to study two more data types, that is your series and data frame. Series and data frame, two more we will cover. Okay, now what? Okay, let us understand. Okay, what series is and what pandas is. Series is 1D labeled homogeneously typed array. Okay, homogeneously typed means that means all the elements. Okay, just like in your array, just like in your array exactly. Okay, all the elements of a series should be of same data type. Okay, then next is your data frame. Okay, the data frame is general 2D labeled size mutable tabular structure with potentially heterogeneously typed columns. Okay, that means it is two dimensional. First means 2D, 2D labeled, that means it is there are two dimensions, that means rows and columns. Okay, first thing. Second thing, it is size mutable. Size mutable means that means if you want to change the size of the data frame, we can do that. Okay, if you want to, let's say, add new rows, okay, or delete existing rows, or if maybe add new columns or delete existing columns, that can be done easily in case of data frame. Third, it is a tabular structure, rows and columns. Fourth, heterogeneously typed column. That means each and every column of a data frame can be of different data types. Although all the elements of the same column will be of same data type. Okay, but different columns can be of different data types. Let us say we have this file with us MBA file. Okay, so here you can see if I take this data, if I take NBA stand for your National Basketball Association. So if I take this data, okay, and I load this whole information, this whole data set into the Python memory, okay, that will be stored as a data frame. That will be stored as a data frame. So here you can see there are different columns. Name column is there, team column is there. In both of them, the data is present in string format. Okay, then there is a number column. In number column, the data is present in integer format. Then position column, again string data, age column, integer data, and so on. Okay, so this is how class these things work. So now let us understand what data frame is. Okay, let us understand what data frame is, how it is created. Okay, now first way to create a data frame, okay, is by typecasting it from a list. It is by typecasting it from a 2D list basically. Import pandas as PD. Okay, let us import numpy also. Okay, right now we don't need numpy, but later on we might require as np. So we have done. Here you can see it is still showing star here. Star means that means that cell is still running. Okay, and pandas is a very heavy library. It is a very heavy library, so you can see it was taking some time to import it. Okay, then let's continue class. We are creating a 2D list first. Okay, let's say L2 is equal to two-dimensional list. That means list inside list. Okay, so first I will create here, let's say A, comma, 10. Add another list here, B, comma, 20, let's say. Another list, E, comma, 20. Here you can see class that this is a two-dimensional list. Okay, can see this like this. Okay, in this case, you can see there are 3 rows and 2 columns. There are 3 rows and 2 columns. Now, suppose if I create a data frame out of it, so I can write a df is equal to pd dot data frame. Okay, so you can see it will create a data frame out of it, ABC 10, 20, 10, 20, 30. Here you can see class, there are index values which are being used here 0, 1, 2. Okay, so these index values are given by itself. Okay, the index values come by themselves. Okay, similarly, there are column names also. Column names is also there, and these are your index values. Okay, so this is a data frame class. Now, if I create a series of the same data, okay, suppose if I write here S is equal to is L. Okay, so here you can see it will create a series. So in this case, you can see the data is present in one dimension, single dimension only. That's it. Okay, this is your single dimension data. This is your indices or index values. So here data is still one dimensional. Okay, even though each and every element is separately a list. Okay, similarly, we can create series in another manner class. Okay, we can create series in another manner. Suppose you have a one dimensional list or one dimensional array or a tuple, okay, or a set. Any of them will do. Let's say I have a tuple with you 1, 2, 3, 4. Let's say, and if you create here st is equal to d dot series of t, so you can see you will get this data. 1, 2, 3, 4 is present as data here. Okay, and rest this is your index values. This is coming separately. Plus series is there. Okay, and data frame whenever you pass a total two dimension, so automatically it will create columns, rows and columns. Okay, now let us see more ways to create a data frame. Okay, next is a dictionary. Suppose you have a dictionary with you class. Writing name here, column, and then inside this you have a list A, comma, B, comma, C. Okay. One more is there 10, comma, 20, comma, 30. Okay, now if I create a data frame out of this, PD dot data frame of D. Okay, so here you can see class. These two are same. Okay, the only difference being here is that here the column names are 0. Here the column name is 0 and 1. Okay, columns name is are 0 and 1, and here the column names are name and score. Okay, because what happens class, whenever you create a dictionary, whenever you create a data frame from a dictionary, so automatically whatever keys you are giving to the data frame to the dictionary will be passed on as column names of the data frame. Keys of the dictionary will become column names of the data frame. Okay, so this is how it works. Okay, here we had not given anything from our end. Okay, let us do one more thing. Let me show you. Suppose if you want to give the column names from your end. Okay, so you can mention a separate argument here called as columns is equal to, let's say, name and score you want to give. Name, comma. Okay, so here you can see the data is coming from a list. Okay, but we are giving column names from our end. Similarly, index values also, if you can give from your end, values can also be anything. Here you can write here index is equal to, let's say you are writing here A, E. Randomly, I'm just showing you Q, or maybe X again. Okay, X again. So here you can see X, E, X. Okay, this is basically your index values. You can give something else also. Q. Okay, so this is how these things work. Okay, here index values are not there, so you can give index values from your end. Similarly, you can pass this argument as here, so index value will also be given. Let's continue class. One more way. Okay, now I'm creating one more. See here, I'm creating dictionary of list. Okay, here now I'm going to create list of dictionary. So this is dictionary of list. Here I'm creating list of dictionary. There is first is your name colon A. Okay, this is your first dictionary. Second dictionary. Third dictionary. Okay, so if I mention here B, T, F is equal to PD dot data frame LD DX. Okay, here you can see exactly same data here, here. Okay, and here we are creating a data frame from a list. Here we are getting data from a dictionary. Here also you can see whatever keys are there in the dictionary. Okay, they are basically automatically going to the column names. Rest all is going to the data. Index value is created by themselves by the pandas library itself. Okay, so these are basically class some ways of creating a dictionary, dictionary, creating a list, creating a data frame from the list and dictionary. Okay, so let's continue. Okay, now let's class next is your till here class we were creating data from our end. Okay, we were creating the data also, we were creating the dictionaries also. Okay, we were creating the list also, and we were creating the data frames also from the data created by ourselves. Okay, now what we're going to do, we're going to take data that is present in our system. Okay, for example, I'm taking this NBA file. Okay, so here you can see NBA file and my code. Both of them are present in the same folder. Both of them are present in the same folder itself. Okay, now I'm going to take this. Okay, now I'm going to take this NBA file, okay, and load the whole data into the pandas data frame. Okay, so here you can see there is a file 1, 2, 3, 4, 5, 6, 7, 8, 9. There are a total of 9 columns. Okay, total of 457 rows. 9 columns at total of 457 rows. Okay, so let's continue class. Okay, this is a CSV file. Okay, let me show you. This is the CSV file. Okay, you can see comma separated values. What is the meaning of comma separated values class? Suppose if you see, if you simply open it, it will open in an Excel file. Okay, or one more thing that you can do is you can open the file in Notepad also. Okay, how? You can go here, open with Notepad. So here you can see class, this is a comma separated values. Okay, name, comma, team, comma, number, comma, position, comma, and so on. Avery Bradley, comma, Boston Celtics, comma, okay, 0.0, comma, and so on. Okay, this is basically your NBA file. Okay, it is in CSV format. Okay, now there are multiple reasons class why .csv file format is preferred, okay, over your Excel format. Okay, first reason being class, and your Excel file, okay, is heavier than the CSV file. Heavier means we require more amount of space. Okay, more amount of space to store a Excel file as compared to CSV file. Okay, the CSV file, the same CSV file. Here you can see, in this case, the CSV file is taking 32 KB, right? If I create an Excel of this file, if I save this file as an Excel in the Excel format, then this file will take approximately 40 KB of memory space. Okay, and there is very less amount of data in this case, like around 457 data values, data records only. Okay, because in data analysis, data science, your data records can go as high as in thousands and lakhs also, depending on the sector, depending on the application that we're working on. The data records can go in thousands, okay, and sometimes even lakhs. Okay, so let's continue now. First reason I told you, CSV. Okay, heavy, light. Second reason is plus that CSV file can be opened in a notepad file. Okay, you cannot open Excel file into notepad. Okay, so what is the benefit of this? Okay, the benefit of this is that since CSV file can be opened in notepad, and since notepad can be opened, notepad files can be opened plus in every operating system without installing any additional software. If you want to open Excel file, you will need to install Microsoft Excel in your computer, okay, or some other Excel opener you need to install. Okay, but in case of CSV file, okay, we just need Notepad. Okay, and Notepad comes pre-installed with every operating system, be it your phone, be it your Windows, be it Mac, be it Linux, or be it any other operating system. Notepad files can be opened there. Okay, so now let's continue, class. These are the two reasons. Let's continue from here. Okay, now what I'm going to do, I'm going to take this file, okay, and load the whole data, all this data into the Python memory. So how do we do that? We will write here. Okay, NBA is equal to just a variable I'm creating is equal to PD dot read underscore CSV. Okay, and the file name. So here I will mention the file name nb.csv. So here you can see, class, it is loading the whole data, all the data into the Python memory. Okay, obviously it is truncating here. It is not showing you everything. Okay, because of setting that is done in pandas. Okay, that setting is PD set underscore option. Okay, and then display dot max underscore rows. Okay, and here, class, the by default value of this is 10. By default value is 10. Okay, but what we can do, see, that is why it is showing 10 only. See how many maximum rows, how many it should display 10. Here you can see it is showing 10, 5 rows from the starting. Okay, and 5 rows from the end. Okay, if you want to see all the rows, okay, then you can set it to none value. Once you do this, okay, and you go back here and you read the file again, here you can see, class, all the data records it is showing to you. Everything that is there in the file. Is everything. Okay, the last person here is also Zef. Okay, all the data it is loading into the Python memory so that we can analyze the data, so that we can analyze the data according to our requirement. Okay, let's continue now, class. Okay, see, just see what happens. Right? Basically, whenever your mouse comes here, it will start scrolling. Okay, so that is why we don't need everything. Okay, what we do, we'll run this code again. Okay, and then here we'll take this file again. Okay, because see, obviously all the data is loaded, but it is just not showing you. Say display.max underscore stem. So it is just not displaying it to you, but believe me, all the data has been already loaded. Okay, so now, class, this is how we read a CSV file from the computer. Okay, now suppose the CSV file is present in some other folder. Okay, then you will have to mention the whole path with forward slashes, just like I showed you in file handling. Just like in the same manner, yeah, we will do it here too. Okay, now let's continue, class.
Sir, can you please show it again? The whole path.
Acha, whole path. Okay. Saving this file on let's say on desktop folder. Doing it here. Okay. So now what I can do, I can go to properties here. I can copy the whole path. Mention it here. Or like showing you, I'm changing the file name also. NBAQ. That's it. And here I will change it slash all the backward slash to forward slash desktop slash NBAQ dot CSV. So if I run this code here, you can see it is loading the whole file. Obviously, the file is same, the data will also will be same. Getting it now?
Okay. Thank you. Yes.
Okay. Can you present in any folder at all? But you just need to mention the whole path. That's it. Okay. Now, class, this is where basically when the file is stored in our computer. Let's say the CSV file is not present in your computer. Let's say the CSV file is. Acha, one thing. Okay. By the end of this, at the end of the class, remind me. I will just share this file also. I will share this Excel file with all of you. In Teams, I guess it is not allowed, no? Can we share files? No, I guess, right? Port link.
So you can share it in the Google Classroom.
I will upload it in the Google Classroom, or I will just give me a minute. I already have the file online. I will just download it. I will just share the link with you. Wait. Or all of you must be having the access to the drive folder, right? All of you must be having the access to the drive folder, right?
So better to share in classroom, sir.
See, classroom. Okay, actually, I have logged in actually from a different account, so it will take time. Just give me. Okay, class, I have shared a link with all of you. You can download the file from here. In the chat, I have shared a link. Okay, so let's continue. Okay, so this is how we read a file. Yes. Okay. Now, class, I was telling you about that if the file is present in the computer itself, then this is how we do it. Let's suppose the file is present on the internet somewhere, maybe. Okay, let's say we will take our data set called as airlines data set. Okay, let's say the file is present online. Okay, so here you can see this data set is present here. Okay, online on this website. Okay, let me share this link also. Okay, I've shared all both the links on the chat. Okay, now here what I can do in this case, I can go to clicking on raw here. Okay, here you can see this is the whole CSV file that is there. Okay, only 3 columns: year, month, passengers. Okay, never mind. Okay, so we will copy this link, and here we can paste the link here itself. Now I can write air like air, whatever variable. Okay, pd dot read underscore csv, same function. Here inside quotes, we'll mention the whole link. Okay, so you can see that the whole data, whatever data is there, okay, in this case will be loaded here. 144 rows and 3 columns. Okay, if the data is present online somewhere. Okay, remember it should be present in .csv format in the end. Okay, then and then only you can download it. Okay. Here, if it is written on GitHub, then click on raw. Okay, because you know, or much more, a lot of information is there, right? All this information are also there. Code issues, pull request, all these things are also there on this particular link. Because we don't need all this. We just need the raw. We just need the raw data. That's it. So this is how we download the file from the internet. Okay. Then there is one more way. Okay. There is one more way. I will cover it later on. Okay. Once we cover, okay, that is actually a separate topic altogether. Okay. So now let's continue class. In this case, we are reading a CSV file. Now let's say if you want to, if we have an Excel file in our computer, if we have an Excel file and the file format of the Excel file is .xlsx, xlsx. This is the format of your Excel file. Okay, so what in the case of Excel file, what you can do? Simply like here we are doing this. So in the case of Excel file, you're going to write here pd.read underscore Excel. Here nb.xlsx. Okay, right now the file is not there. Okay, that is why it won't work. It will throw error right now. Okay, but if you have any Excel file class, you can create some Excel file from your end also if you want to. Okay, so if you have an Excel file, you just need to do this. Okay, once you run the cell, okay, everything will all the data. I have not run the cell. I'm not running the cell right now, but otherwise it will show you all the data. Now let's continue class. Okay, so here we know multiple ways to load to create a data frame. First is your by typecasting that we saw here. By typecasting, in this case, we are loading the data from our computer hard disk. Okay, in this case, we are loading the computer from the loading the data from the internet. Okay, and here we are loading the data from an Excel file. Multiple ways we know to create a data frame. Next is class. Whenever you are reading a CSV file, so in this case you can see by default. In this case you can see by default the data is present like this 447 and 9 columns. Okay, whatever data is there is present in data format only here, and the index column is created separately by the Panda itself, and it is sequential always, obviously starting from 0. Okay, and the topmost column of your Excel of your CSV file, name, team number, okay, that will automatically become your column names. This is what happens in this case. Now let's suppose if you want to set your own index column. Set your own index column. Suppose in this case you want, let's say, the number column to be the index column. Okay, so here you can see this is 0, 1, 2. This is column number 2. Okay, so what we can do while we are reading the file, you can write here underscore column is equal to 3 is equal to 2. So here in this case you can see the number column has become a index column here. Okay, and see earlier it was showing you 9 columns. Okay, now it is showing you 8 columns only because the number column has become the index column, and rest all columns are basically part of your data by default. So we can set our own index column also if we want to. Let's continue now class. Okay. Next is your indexing. Indexing means like taking out some specific information, okay, from the data frame. Now before starting it, let me explain one thing class. I told you about series, I told you about data frames. Series is homogeneous. Your data frame is heterogeneous. And when we say heterogeneous, it is heterogeneous in the sense that each and every column, okay, can be of different data type inside a data frame. Here you can see string, 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 float, string, float, string, float. Okay, and this is your again float. Index column is also in the float format here. Okay, so now in this case, each and every column can be of different data type. But you can see one thing, that all the elements of the same column are of the same data type. That means that each and every column of a data frame can be individually called as a series. Okay, that means that this position column is a separate series, age column is a separate series, height separate series, weight separate series, college separate series, salary separate series, and so on. Team also, name also, all of them are separate series. So what we can do, class, while we are indexing, okay, you can write here NBA. NBA is basically where this is there. This is NBA, where 0, 1, 2 is the index values. And what is NB? NB is your where the index number is the index column. So I'm taking NBA right now. And I will write here NBA. Here you can see, class, it is showing me this in series format. Okay, you can check also if you want to. Okay, you can save it in some variable. Let's say Q is equal to this. And then right here, type of Q. So you can see it is showing you pandas.co.core.series.series. Okay, this is your series. Okay, so similarly, each and every column, okay, of the data frame will be called as a series. Okay, now this process is called as class column indexing. Okay. Now let us see next. Next is a multi-column indexing. Now class, multi-column indexing is slightly very small difference. What is that? Okay, you just need to pass list of lists for multi-column indexing. Here you can see we are passing just data here. Okay, inside the square brackets. In case of multi-column indexing, instead of passing column name, we have to pass column names inside a list. How? Okay. Like this. So now you can see this is in this case multi-column indexing because multiple columns might be there. In this case, it is there is not. Okay, it is not there. Okay, but still there might be possibility is there because we have mentioned a list. We have inside the index where we mention the index value. There we are sending we are giving a list. Okay, so multiple columns can be there. Okay, so that is why it is returning the data in data frame format. Now class, what we can do? Let's take this. Okay, now we will take multiple columns also. Okay, multiple columns. So you can just mention comma. Here, let's say we want to take the position column and the college column. Name, position, and age. Let's name, position, and age. So you can write your name, position, comma, age. So if you run this code class, here you can see that all these three columns are separately coming from the whole data frame. Okay, now if you want, you can save it in separate data frame also, just like we saved it in a Q variable, this series. Similarly, you can, if you want, you can save it in separate data frame also. If you want to run a separate analysis on it. This is what we do, class. Whenever we are working on data analysis and data science, in this case, sometimes what we do, instead of taking the whole data set in one go, okay, we take chunks of small chunks of the data set. Okay, we don't analyze the whole data set at once. Right now, there are only 457 rows and 9 columns. So it is fine. Not a big issue. Okay, but in majority of the cases, what happens? Not majority. Okay, it depends on the applications also. It depends on the sector also. Okay, healthcare sector or finance sector. Okay, or your sports sector. Okay, or your education sector. Whatever sector is there. Okay, depends on the like from which sector the data set is coming from. Right now, the NBA data set is from the sports sector. That means your basketball. Okay, so it depends on that also. So there can be multiple columns and there can be numerous columns. Right now, there are only 9 columns. Okay, but the number of columns can go as high as 50, or sometimes even 100, or sometimes even more than 100 columns also. Okay, so at that time it will be difficult for us, okay, to work on all the columns in single go. Okay, in one go we cannot work on all the columns. It is not possible. For rows also. Let's suppose the rows are basically in data records are there in lakhs. Okay, there is 2 lakh data records. Okay, let's say about the data is about let's say number of accidents in India. Let's say. Okay, so in that case there is a possibility that like for the whole year, okay, maybe there are 2 lakh accidents all over India. Okay, so there are basically data records of 2 lakh people, okay, who had an accident, okay, in the past year, let's say in 2021 maybe. Okay, so in that case it will be completely difficult for us to analyze all those 2 lakh data records in one go. So in that case, what we do, we take small chunks. We don't take the whole data set in one go. We take small chunks and then analyze them. Okay, and then small chunks are analyzed, and then we combine the analysis, okay, with the analysis done on the whole data set in one go. That also we do. To understand, see, the whole idea is to understand the data better. What the data is giving us, okay. Okay, the whole idea is to obtain confidence in the data. Okay, if the data, what the data is giving us, okay, what the data is all about, okay, if the data that we're getting, okay, that data is accurate or not. Okay, maybe there might be some discrepancies, maybe there might be some incorrect data also. Okay, or maybe there might be some spelling mistakes. Okay, let's say there might be some spelling mistake in, let's say, a name column maybe. Okay, or in the position column, instead of writing PG, okay, suppose they wanted to write PF. Okay, and by mistake they wrote PG there. Possibly. Okay, let's assume for that. Okay, so that is also a possibility, because in this is a normal thing. This is a normal thing to happen in data sets. Okay, so all of these things we need to basically we do a proper study of the data set, okay, that we're getting, in order to understand what kind of data we're getting, okay, and if there are columns in the data set, so that the end goal is to prepare the data for the machine learning model that we are going to run on it. Okay, see, there are two ways. If you are a data analyst, okay, so as a data analyst, you will just analyze the data and you will prepare a report. Okay, and that report will be basically answering multiple questions. Suppose, let's say we have that accident data set. Okay, so in that case, let's say the client is asking you, let's say the client is maybe, let's say Delhi police is the client, okay, of your company, okay, and they are requesting multiple information from you. Okay, so they will give you some specific questions to work on. Okay, so let's say one of the questions is, let's say that which is the which reason due to which reason there are most number of accidents in 2021. Due to which reason there were most number of accidents in 2021. Okay, then second question can be, let's say that, okay, at which time of the day, okay, the most of the accidents happen. Let's say at 6 p.m. maybe, okay, or in the morning maybe, or somewhere in the night maybe. Okay, at what time, okay, most number of accidents happen. Okay, or let's say which area, okay, in every city, let's say in every city you have to identify 10 areas, okay, which are prone to accidents, where maximum accidents happen in every city, or let's say in every state, okay, all over India. Okay, you have to tell 10 such places where most top 10 places, okay, where accidents happen, okay, in every state. Okay, now let's say one more question can be, for example, uh, in this case, okay, survival rate, okay, in the accidents. Okay, what is survival rate state wise? Okay, so like if the person is able to survive the accident or not. Okay, so there can be three categories, maybe 0, 1, 2. Okay, 0 means the person didn't survive. 2 means, okay, the person survived and there was no injury also. And 1 means that the person survived, okay, but with injuries. 0 means the person didn't survive. Okay, so see, this is how the things work. Okay, this is how we basically prepare the data. Okay, and there can be multiple questions. So as a data analyst, you will have to answer these questions. You have to prepare a report, okay, based on your analysis, okay, and submit it to your client. Okay, as a data analyst, that will be your main task. Okay, and second task of of yours will be, suppose that there is a whole project. Okay, in the whole project, that let's say the police is asking you, okay, state police, okay, whatever it is state, okay, the state police is asking you to predict the number of accidents that are going to happen in every state, okay, in 2022, let's say. That is the prediction. Okay, or let's say predict that which reason is going to be uh, that due to which reason most number of accidents will happen in any state. Okay, that is, let's say, this also you have to predict. Okay, so now this is an application of data science where prediction comes. Okay, that is an application of data science. Okay, once, and where analysis is there, that is your application of data analysis. Okay, so now if the project is, if the police is asking you, okay, if the state police is asking you to give the prediction also, then as a data analyst, if you're a data analyst, okay, there will be in your team, there will be there will be data analysts also, there will be data scientists also. Okay, so in that case, as a data analyst, your task will be to prepare the report and also to prepare the data, okay, to obtain confidence in your data so that the data can be used smartly in the machine learning algorithm that is going to be run later on. Okay, because see, obviously there might be some redundant data also in the data set. Okay, maybe let's say in this accident data set, okay, maybe let's say you have um, let's say you have wait a sec. This accident data set, let's say you have educational qualification, okay, of the injured person. Let's say education qualification. So do we need education qualification of an injured person? No. Okay, because when an accident happens, okay, so if the person is educated or not, it does not matter. Okay, so in this case, that data is redundant for us. Okay, and if you feed this data to the machine learning algorithm, it will unnecessarily hamper the learning in machine learning. Okay, in machine learning, it will unnecessarily hamper the learning. So as a data analyst, that is your task to understand what data columns you have. Okay, which columns are more important, which columns are less important. If they're important, how much they are important. Okay, we basically provide a weightage to all of them one by one. Okay, let's say weightage means like how percentage. Okay, let's say, okay, this column is 10% important. This column is 20%. This column is 50% important. Okay, that is going to affect, let's say, if the person is drunk driving or not. If the person is drunk or not while driving, okay, that is one of the main reasons, okay, why accidents happen. Okay, so now in this case, this particular column, yes or no, okay, drunk, column name will be drunk, and inside that yes or no will be written. Okay, or 0 or 1 will be written. Okay, so in this case particularly, okay, in this case particularly, okay, when you're working on the trunk column. Okay, so here in this case particularly, the data, the trunk data is is most important. Okay, so in this case you can mention it. Okay, 50% weightage. Okay, or in machine learning terms, we say it as 0.5 weightage. 50, not 50%, 0.5 weightage. That means that this is one of the major factors, okay, why accidents happen. Okay, so that we provide weightage to each and every feature that is there. Okay, some columns we completely drop. Okay, let's say education column, okay, of the injured person of or maybe of the driver, we can drop that completely from the data set because we don't need that. Okay, so that will be your task as a data analyst to understand the data, okay, to see discrepancies in the data and all. Okay, next thing will be, once the data is prepared, okay, then the data will be fed to a machine learning algorithm, and that is written by a data scientist. Okay, data analysis plus machine learning is equal to data science. Okay, I hope all of you got a like complete idea, right? Not complete, obviously, but a lot idea, right? How things work. Am I audible? Hello.
Yes, sir.
Yes, sir, you are audible.
So now let's continue class. Okay, so we are working on multi-column indexing. Now next is the class row indexing. Next is row indexing. Okay, so first let us say single row indexing. Single row indexing, again the output will be present in your series format. Remember that each and every row of the data set can be individually taken as a series, just like column. Suppose if I write here, in this case, nba.loc. Okay. Now to access the rows, there are index values. Okay. So let's say if I enter, maybe I want data about, let's say J Crowder. Okay. So index value is 1. So I can mention here nba.loc 1. So you can see it is giving me the data in series format. This is your data about J Crowder. Okay. And here, this is your index values. Okay. Now there is one more way class. Okay. That is your multi-row indexing. Is your multi row indexing. Okay, so how it works? Same thing, NBA dot LOC. LOC means location class. LOC means location. And just I need to put double bracket here. 1. So you can see it is giving me data in data frame format now. Okay, if I want to take multiple columns, multiple rows. So I can mention, I just need to mention the rows. Row indices. Let's say I want 52, maybe 128 row, maybe let's say 350. Here you can see it is giving us all those 4 rows, whichever we have passed here. Okay, so this is your class multi-row indexing, and this is your single row indexing. This is your multi-column indexing. Okay, and this is your single column indexing. Okay, now let's combine both of them. Let's combine. Here you can see this is giving us a data frame, no? This is a separate data frame. So now I can apply column indexing on this particular data frame if I want to. Okay, this is the output, right? Now here I can write, I want name column and team column again. So I can mention here name or team. Here you can see for all those 4 people, it is giving us just name and team column. Okay, so here first we're doing row indexing, and then we're doing column indexing. Now this can be done in reverse also. How? Just take it. First do column indexing and then row indexing. First I've done column indexing. Okay, and then on it I am applying row indexing. exact same output in both the cases. Okay, so class, this is how these things work. Okay, now let's say if I do the same thing on NB column, NB data frame. In the NB data frame, the index values are different. Okay, now suppose if I'm doing this simple nb.loc1. So here loc1 is giving us J Crowder, right? If I write here nba.loc1, okay, on the NB data frame. Okay, so here in this case, you can see for whichever values, for whichever people there was one was taken, one is the index value. Okay, one is the index value. It is showing data for all of them to me. 20 rows, 8 columns. Okay. Now suppose in this case on the NB data frame, I need the data for J Crowder. Okay, so in this case class, there is another method. Okay, when the index values are different from 0, 1, 2. Okay, then there is a separate method called as ILOC. Same thing I can mention here as ILOC. So ILOC means class integer based indexing. Integer based indexing, because what happens? Let's understand. Whenever a data frame is created, so automatically in the backend, your pandas will also maintain one more index column. 1, 2, 0, 1, 2, 3, 4, and so on. This will be your 456. Okay, so your data frame will pandas will maintain one more index column, and that is called as integer based location. This is location, and this is integer based location. ILOC, and this is your LOC. Okay, so even see integer based location will always work. Okay, if the index it will work on the NB data frame also, on the NB also. Okay, but your location is completely dependent on the index values. So that is why ILOC is also there. We sometimes see simple thing here. In this case, in the case of NB data frame, the index values are continuous in nature. Okay, but in the case of NB data frame, the index values are not continuous. 0 ke baad 99, then 99, then 30, then 28, then 8, and so on. They are not continuous. So that is why to run for loops and all, we need something, okay, so that we can make it as continuous. That is why your ILOC is present. Okay. So here you can mention, you can take this whole thing. Add this on NB, it will throw error. Okay, because it will not be able to find all this. 128 is not there in the number column, in the number index column. 356 is also not there. But if I write here ILOC, okay, we'll get the same output. See, here also J Crowder, Carl, Alex, and Aaron. Here also same. J, Carl, Alex, and Aaron. Okay. So, yep, that is all for today class. Is there any doubt, anyone? Is there any doubt in whatever we have covered today?
Sir, can you show the syntax for that NB?
Or ILOC?